On the 6th of April, 2026, 4 humans traveled farther from Earth than anyone had since the Apollo mission. For about 40 minutes, they lost all contact with Earth. Not because their spacecraft malfunctioned, and not because the communication system failed, but because the moon itself stood between them and Earth, completely blocking every radio signal. For those 40 minutes, Mission Control in Houston heard nothing. No voices, no biomedical data, no emergency signals. More than 406,000 kilometers from Earth. If anything had gone wrong on the far side of the moon, no one would have known, and no one could have helped them. Those 4 astronauts were Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, the crew of Artemis II. For that brief moment, they became the most isolated human beings ever to leave Earth. At 6:35 p.m. on the 1st of April 2026, Orion left Earth. Over the next 5 days, the spacecraft followed a carefully planned path toward the moon, traveling more than 406,000 kilometers before reaching the lunar far side. Once the mission began, there was no simple way to turn around. Every engine burn had to happen at exactly the right moment. Missing one by even a small margin could change the entire trajectory. NASA planned for that possibility long before launch. Artemis II followed a free return trajectory, allowing the spacecraft to swing around the moon and head back toward Earth even if its main engine failed. Apollo 13 depended on the same path after an oxygen tank exploded in 1970. More than half a century later, NASA still trusted the same approach for its first crewed mission, beyond low Earth orbit. 5 days after launch, Orion reached the far side of the moon. Then the radio went silent. When Orion passed behind the moon, the view changed completely. For the next 40 minutes, the crew flew above a landscape that no one on Earth could see in real time. The side of the moon facing Earth is easy to recognize because dark lava plains cover about 31% of its surface. The landscape below Orion looked very different. Less than 1% of the far side is covered by those plains. Almost everything else is made up of overlapping impact craters that have remained exposed for more than 4 billion years. The difference isn't only what you see on the surface. Data from lunar orbit shows the crust on the far side is about 50 kilometers thicker than the crust facing Earth. Scientists still don't know the full reason. One leading idea points to a massive impact near the moon's south pole early in its history. That collision may have pushed heat and radioactive elements toward the near side, where volcanoes later covered older craters with lava. The far side cooled differently, leaving its older surface largely unchanged. The same impact also formed the South Pole Aitken Basin. It stretches nearly 2,500 kilometers across and reaches almost 13 kilometers deep, making it the largest preserved impact basin in the solar system. Orion flew across part of its eastern rim, giving the crew their first direct view of one of the oldest landscapes in the solar system. The astronauts could only see the surface. Scientists believe the bigger discovery lies hundreds of kilometers below it. After analyzing gravity measurements from NASA's Grail mission, researchers found evidence of an unusually dense mass buried beneath the South Pole Aitken Basin. It lies at least 300 kilometers below the surface and weighs an estimated 2.18 quintillion kilograms. To picture that amount of mass, one researcher compared it to burying a block of metal 5 times larger than the island of Hawaii beneath the moon's crust. The object is so massive that it appears to pull the floor of the basin downward by more than 800 meters. We still don't know exactly what is hiding down there. It could be the remains of the impact itself, preserved deep inside the moon for billions of years. Or it could tell us something about how the moon's interior changed after the collision. Either way, the surface tells only part of the story. The real mystery lies hundreds of kilometers below it. If that ancient impact really reshaped the moon's interior, it may have left behind more than a buried mass. Another clue could be hidden beneath the same hemisphere. Scientists have also found a region about 50 kilometers wide that gives off more heat than the surrounding terrain. The temperature difference is only about 10 degrees Celsius, but it shouldn't be there. The most likely explanation is a large body of granite, buried beneath the surface. On Earth, granite usually forms when magma cools slowly beneath continents. Finding evidence of it on the Moon suggests that at least one part of the lunar interior remained active much longer than scientists once expected. One possibility is that this heat comes from the remains of an ancient volcanic system that formed around 3.5 billion years ago. If that's true, part of its magma chamber may still be releasing heat today, long after the volcano itself disappeared. That isn't the only reason scientists think the Moon's interior may still be changing. Seismometers left behind by the Apollo missions recorded shallow moonquakes for years after the astronauts returned to Earth. The Moon wasn't erupting with volcanoes, but it also wasn't as motionless as it first appeared. Each new discovery points in the same direction. The Moon looks quiet from orbit, yet beneath its surface, it still preserves signs of a much more active past, one that scientists are only beginning to understand. As Orion passed behind the Moon, the Sun disappeared behind the lunar horizon, creating a total solar eclipse that lasted nearly 54 minutes, far longer than any total eclipse visible from Earth. Around the edge of the Moon, the Sun's corona spread into view, forming a ring of light that remained visible for almost an hour. That wasn't the only thing the crew noticed. During the eclipse, they reported brief flashes appearing across the lunar surface. Some may have been small meteorites striking the Moon, where even tiny rocks reach the ground without burning up in an atmosphere. Others may have been something far less understood. For centuries, astronomers have occasionally reported similar flashes, known as transient lunar phenomena. Some are linked to impacts. Others have been explained as electrostatically lifted dust or gas escaping from beneath the surface. The crew had less than an hour to watch before Orion emerged from behind the Moon and radio contact with Earth returned. Whatever caused those flashes, they became part of a mystery that scientists are still trying to solve. There was another danger the crew had to face, and it wasn't coming from the Moon. It was coming from the space around them. Artemis II flew during the peak of the Sun's roughly 11-year cycle, when solar activity can produce powerful bursts of radiation. A major solar particle event could expose the crew to dangerous levels of radiation within hours. Orion has more protection than the spacecraft used during Apollo. Even so, some radiation passes straight through the vehicle. Galactic cosmic rays are especially difficult to stop. These particles travel close to the speed of light and come from events such as supernovae that happened long before humans existed. Apollo astronauts had already experienced one strange effect. They reported seeing brief flashes of light while their eyes were closed, even during sleep. High-energy particles were passing through their eyes and triggering signals in the retina. The exposures during Apollo lasted only a few days. Deep space missions would last much longer. If a solar particle storm had struck during those 40 minutes behind the Moon, mission control would have had no way to know exactly what was happening until the signal returned. The crew had procedures for a radiation emergency, along with equipment designed to keep Orion's cabin pressurized and the astronauts protected. None of that, however, could change their basic situation. 4 people were sealed inside a spacecraft roughly the size of a large van. Between them and Earth was more than 3,400 kilometers of solid Moon. And during those 40 minutes, no one could reach them. That is why radiation may become one of the main limits on human exploration beyond the Moon, something much harder to see. Particles moving through space, passing through the spacecraft and through the human body without making a sound. The damage may not appear until years later. When the signal returned after 40 minutes of silence, Mission Control in Houston finally knew that the crew was safe. The flight continued for several more days before Orion plunged back through Earth's atmosphere. For about 13 minutes, friction heated the air around the spacecraft to extreme temperatures, putting the heat shield through its most demanding phase. The shield had previously shown several design issues that NASA needed to monitor closely throughout re-entry. On the 10th of April, 2026, a series of parachutes deployed and slowed the spacecraft's descent. At exactly 8:07 p.m. Eastern Time, Orion splashed down in the Pacific Ocean, off the coast of San Diego. U.S. Navy divers reached the spacecraft and helped the crew out onto an inflatable boat. From there, a helicopter carried them to the USS John P. Murtha, where they underwent medical checks. Artemis II did not land on the moon, but it showed that the lunar far side may be far more active and complex than scientists had assumed for more than half a century. Artemis III will take the next step. This time, humans are planned to return to the lunar surface, landing near the South Pole, where some of the moon's biggest remaining mysteries are concentrated. Water ice may have remained trapped there in permanent shadow for billions of years. The question is no longer whether the moon still has more to reveal. It's whether, when humans finally step into that landscape, we will be ready for what lies beneath the dust.